Broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. My name is Catherine. I'll be your webinar facilitator today. Thank you for joining us for the expansion of DZK to FXSQ and FDMQ webinar. As a brief reminder, all lines are currently on mute to prevent background noise. If you have questions during the presentation, go ahead and type them into your chat box. We'll be happy to answer at the end of the webinar. This afternoon, I'd like to welcome Kevin Miller, VRV Indoor Unit Product Manager. Kevin, you may now begin the webinar.
Thanks, Catherine. Thanks, everybody, for listening in. So today what I'm going to go through is an overview of the DZK, which is the Daikin Zoning Kit, and talk about some of the changes that we've introduced to the DZK lineup to support the connection of the DZK to the FXSQ, S as in Sam, and the FDMQ indoor unit on the single and multi-zone systems. So the agenda for today looks a little something like this. I'm going to go through an overview of the DZK. So if you're familiar with the DZK, this will be, I think, a good time to kind of review and refresh on some of the features and functionality of the DZK. We'll look at the model nomenclature, the model lineup, and the compatibility between the different compatible indoor units with the DZK system. And then I'll look through how exactly the DZK works, the features and functions of the DZK, including features like global ventilation, local ventilation, and the integration of auxiliary heat control using the DZK's logic. And then we'll look at the available thermostats in the DZK package, the BACnet interface option that we can use with the DZK, and then I'll look at a quick review of sort of an installation schematic and exactly how the DZK wires into the rest of the VRV system, and then we'll look at just a quick look at literature resources for the DZK. So if you're not familiar with DZK, the DZK is a product that we've sold for several years that we position as the Daikin Zoning Kit. And so essentially the idea is to attach a zone damper solution to an indoor unit in the VRV lineup, and now also the FDMQ indoor unit on the single and multi-zone systems to give some zoning flexibility to a single indoor unit. So as you see in the image here, basically each outlet from the DZK has its own thermostat, and it will modulate airflow to that zone accordingly. So an overview of the DZK looks a little something like you see on the screen here. The DZK actually is an insulated plenum box. So the solution as a whole really consists of this factory insulated plenum box and a control board, as well as different thermostats that are available to connect and control each of the outlets from the DZK. So this insulated plenum box is designed to bolt directly to a series of different indoor units in the Daikin lineup. So we already had DZK accessories that are compatible with the FXMQ PB series and the FBQ indoor unit on the SkyAir series. So the DZK that we're introducing or that we're updating and kind of expanding the lineup today consists of a DZK that can bolt directly to the FXSQ indoor unit that we launched last year, as well as the FDMQ for the single and multi-zone. As part of that DZK plenum box, there are zone dampers and actuators that are connected, kind of screw-in actuators connected from the factory. So we can use up to 6 different zone dampers, just depending on the capacity of the indoor unit that we're connecting the DZK to. But we can connect up to 6 different dampers, and essentially each of these dampers has its own thermostat that will control and adjust the position of the damper. So we'll look at how that damper logic works in a little bit of more detail throughout the presentation. But the idea is that we're basically giving this zone level control to individual air outlets from the indoor unit. So if we have this situation where maybe we don't necessarily need to use all of the outlets from the DZK, We can cap unused outlets, and we can essentially disable that actuator within the DZK. If you have zones that are larger than the capacity of a single outlet, maybe you want to join 2 outlets or 3 outlets together, we can actually use some software settings within the DZK to join and kind of connect those outlets from a software standpoint so that the actuator for those outlets, each of those actuators will sort of respond together to the input from a single thermostat so that we can handle a larger zone with a single thermostat. From a control standpoint, the DZK has a control board that's built into the enclosure that you see on the screen here towards the text at the bottom left side of the screen. But essentially that control board wires to the indoor unit on the P1, P2 communication bus. So the DZK has its own internal logic that really aggregates a lot of demand information from each zone, and then in turn will calculate an indoor unit internal set point. So it's not really something that the user sees, but it's something that the DZK uses to help manipulate the capacity of the indoor unit by manipulating the set point that's sent to the indoor unit. And the DZK will also adjust the indoor unit's fan speed depending on how the zones kind of request demand or ask for demand and ask for capacity. So we'll cover both of those in a little bit more detail as to how the DZK actually controls the indoor unit. But just be aware, you have this seamless control integration where from a user standpoint, the user starts to see an interface with the system using the DZK thermostats, and then the DZK sort of takes over that control of the indoor unit to produce the desired result. From a control aspect, there are 3 different thermostats that we'll look at in a little bit more detail that are used to connect and control the response of those zoned outlets. And then we also have a BACnet IP card to basically allow us to start integrating the DZK into a BACnet IP front end. And this is really a huge advantage on light commercial projects where we want to be able to monitor and control each individual outlet and make commands and control the system. But we don't necessarily, in the first iteration of the DZK, we didn't have that capability to monitor and control individual outlets. So throughout the years, as DZK has evolved, we've integrated this optional BACnet card to get that additional level of control from a front end. So we'll look at all of those features in a bit more detail, but just at a high level, that's sort of the idea behind DZK. So from a model nomenclature standpoint, the DZK model number essentially is a DZK, or now there's also a DZKS model that is, we use that S to denote the compatibility with the FXSQ and the FDMQ style of indoor units. The next 3 digits there, 048, those will indicate, it's really indicating the plenum box size. So with the introduction of DZKS, we've introduced a 3rd small, kind of small chassis, small plenum box size, the 015. But that's really just kind of giving you an idea of the size of the plenum box. There's a small, there's a medium, and a large. You'll see the kind of star cross note there on the screen. Keep in mind that the DZK digits, the 048, that doesn't necessarily align directly with the indoor unit's capacity index or the capacity size of each indoor unit. So just keep that in mind and refer to the compatibility charts if you have any confusion about which DZK you should be matching with which particular indoor unit. The E4 in this example or model number example represents the number of dampers in the DZK. So again, with the introduction of the DZKS and that small frame plenum box size, we've also introduced now a very small 3-zone outlet. But depending on the particular DZK option that's being selected, there are either 3-zone outlets, 4 zones, 5 zones or 6 zone outlets. And again, it really depends on the capacity of the indoor unit that's being connected. And so for kind of a more holistic view, refer to the compatibility charts and the model lineup that we'll look at on the next couple slides. The last digit in the model number, the -3, that's simply a designator for the generation of the DZK. So everything current in the lineup today is a 3rd generation DZK product. From a lineup and compatibility standpoint, I won't go through this table in full detail, but I'll draw your attention to the 6 new models of DZKS that are being introduced into the model lineup. So there are 6 new models: the DZKS 015, the DZKS 030, and the DZKS 048. So they kind of come in pairs. There's 3 different sizes, and they're available. The DZKS 015 can be used with either 3 outlets or 4 outlets. The DZKS 030 can be used with either 4 or 5 outlets. And then that DZKS 048 can be used with either 4 or 6 outlets. So if you're not familiar with DZK, the outlet sizes follow a pretty common pattern. Generally, we have sort of pairs of DZK options, and the fewer number of outlets generally results in a larger damper outlet. So, for example, the DZKS 015 3-outlet model uses an 8-inch diameter outlet, and then if you move up to 4-inch or a quantity of 4 outlets, that's a 6-inch diameter outlet. So that pattern is pretty common. Fewer outlets means a larger outlet diameter. More outlets means a smaller outlet diameter. I did want to throw in one quick slide that shows a dimensional reference of the DZKS, just to make sure everybody is aware. We're introducing this DZKS for compatibility with the FXSQ. And if you're not super familiar with FXSQ, it's a lower profile, sort of smaller height indoor unit. So I just want to make sure that everybody is aware that the design of the actual plenum box within the DZKS has been designed in such a way that the height of the DZKS is designed to really align with the height of the FXSQ and the FDMQ. So the FXSQ chassis size is just slightly under 10 inches tall. So I just wanted to point out that the DZKS models, those also measure in at under 10 inches tall. So from a coordination standpoint, no need to worry. As long as you have that kind of 10 inches of ceiling space above the ceiling, the DZKS still makes a suitable accessory to match up with the FXSQ without creating that dimensional conflict. So how exactly does the zone control work for each of these zone outlets? So each DZK zone outlet has its own set point temperature. And so that damper will modulate in response to the differential between that zone set point and the room temperature that is measured by the DZK thermostat. So ultimately, there are 4 available damper position openings. They're not just sort of open and close dampers, but they also aren't fully analog. So you have essentially 4 capacity steps. And so as that room temperature is kind of, we'll talk kind of cooling, for example, as the room temperature drifts from set point, the position of that damper outlet will be opened through these 4 steps. And then as we drive that room temperature back towards set point, the damper outlets will simply close. And at some point, you'll kind of reach essentially a thermo off for that zone. You've satisfied the set point temperature, and we're going to go ahead and close the zone outlet. It is worth being aware that each of these zone actuators, or the damper actuators, has options for configuring minimum and maximum damper position settings. So there are 4 different minimum position settings. There are 4 different maximum position settings. And these are mechanically adjusted in the field. So just be aware, if you have, for some reason you want to always have some air circulation to a zone, we can use this minimum adjustment to get an approximate CFM percentage out of this outlet by limiting the minimum position. And similarly, we can sort of limit capacity and limit airflow if we adjust the maximum damper position as well. So the numbers that you see on the screen are approximate values of the minimum and maximum resulting CFM if the installer chooses to set these mechanical stops on the damper actuator. It really kind of depends on sort of the net demand and net operation of all of the different actuators as to what your actual airflow will be out of the each damper outlet. So we try to publish a range to give an approximate range of what that airflow restriction will be. So when it comes to mode control, the DZK takes all of the information from all the different zones, and it will control the mode of operation from of the indoor unit. So it's worth pointing out that one of the DZK's wired thermostats ends up being configured as the main thermostat for the DZK, and this is essentially choosing the master fan coil of a heat pump system. So the main thermostat is really what's used to drive the mode of operation really of the DZK, but it's ultimately what drives the mode of operation of the indoor unit that the DZK is connected to. So that main thermostat can be used to choose either cooling, heating, the auto mode, dry, or emergency heat operation. So just keep in mind that main thermostat chooses the mode of operation. There's a little bit of complexity if you use multiple DZKs on a heat pump VRV system. Ultimately, one of those indoor units still has to be designated as the master of the heat pump system. But for the purposes of today's presentation, I'm really looking just at how that DZK is controlling the indoor unit mode of operation, and that's done via the main thermostat of the DZK. So the auto changeover logic within the DZK, it's a bit of a black box. Essentially, each of the outlets will have some parameters that are captured by the DZK internal logic, and that mainly consists of that zone's set point temperature, the current room temperature of that zone, and the demand time that that zone has been in either cooling or heating demand. And so essentially the DZK takes this information from each individual zone, sort of aggregates all of this demand together, and it comes up with a calculation that decides whether or not to change the indoor unit mode of operation to cooling or heating operation. So just keep in mind when you're applying a DZK, it's really no different than applying heat pump VRV with respect to how you are choosing to kind of zone out the spaces that are served by the DZK. You can't, even though you're giving this zone level control, you can't do simultaneous cooling and heating. So it's still important, especially in commercial settings, to make sure that the spaces that are served by the DZK still have similar enough load profiles that you don't have, maybe some particular interior zone that's got, a lot of computers and needs cooling all the time. You don't really want to mix that with maybe an exterior zone that's going to need heating in the winter time. So just be aware of how you approach that zoning of spaces, but do be aware that the DZK has this auto changeover logic that will take all of that information into account to adjust the indoor unit's mode of operation. So the user modes are something in the DZK that are used to sort of simplify how the user operates the system. So user modes are really used for sort of simple, intuitive adjustment of set point conditions. So essentially these user modes store pre-configured set points to ease the control for the user. And it's important to note that the main thermostat is the same thermostat that will apply this user mode setting or these user mode configured set points to all zones at the same time. So keep in mind the user modes can be scheduled and they're also configurable in the advanced settings menu. So the easiest way to think of a user mode is essentially like kind of a default setting for, let's just assume we're talking office spaces. Building warm up happens and we want to set the occupied mode for all zones. We can use this user mode approach to apply all of the same set points to all zones at the same time. But that doesn't mean that the local user can't override the zone settings if they, if you use user mode to send a command of 75 Fahrenheit to all zones, the local users can still adjust that set point. This is just a way to kind of broadcast pre-configured set points to all zones at the same time. So what user modes are actually available? There's a comfort user mode. So that icon looks sort of like a house with a thermometer inside of it. The comfort user mode, it's pretty much the typical sort of de facto standard comfort operation user mode. So the comfort user mode allows the configuration of a cooling set point anywhere from 64 to 86 Fahrenheit, a heating set point anywhere from 59 to 86 Fahrenheit. And really the thought here is, in a residential use for DZK, this is basically like a home setting. I'm back at home, broadcast this setting to all of the zones in my home. In a commercial use, this is really more like an occupied setting. So again, maybe it's 8 a.m. We want to set the DZK to the comfort user mode and broadcast that default temperature setting to all zones at the same time. The eco user mode, it's very similar to comfort, but the idea behind the eco user mode is to store more energy efficient operating set points to be broadcast to all the zones. So we would typically use a higher than normal cooling set point, a lower than normal heating set point, but for the purposes of the configurable range of set point options, it's the same as that comfort user mode, 64 to 86 Fahrenheit, 59 to 86 Fahrenheit for heating. I do like to point out, I don't have it on the slide, but there is a lot of intelligence into the algorithms that control the DZK operation and ultimately control the indoor unit operation, sort of behind the scenes when the DZK is communicating to the indoor unit. So it's worth pointing out that the eco user mode adjusts some of these internal algorithms that control the indoor unit. So even though it seems as though the idea behind eco user mode is simply to store different set points, higher set points result in better energy performance and cooling operation. There's also some changes in logic that will essentially try to optimize the performance of the VRV system as much as possible by limiting set point demand and limiting what would ultimately result in higher compressor speeds by trying to sort of massage the system into delivering these energy efficient cooling and heating set points. So just keep in mind the eco mode is there to really sort of maximize the operational efficiency of the system, both from a set point standpoint, as well as how that DZK is manipulating the VRV indoor units operation. There's a nighttime user mode. Really, this is probably more specific only to residential use, but the nighttime user mode is something that's used to essentially also save energy by setting back the set point over time. So what happens is when the nighttime user mode is initiated, essentially every 30 minutes, the DZK will start to adjust the set points of the zones by 1 degree every 30 minutes. So ultimately, in cooling operation, you'll raise the target set point by 4 degrees over 2 hours. And the idea is essentially, we'll slowly allow the system to drift to these more energy efficient set points, but it's ideally happening after the homeowner has already gone to sleep. There's an unoccupied user mode. Looks a little bit, the icon that would be seen on the screen looks like a little man kind of walking out of a house. But this is really ideal for unoccupied operation. In a residential use, the user is leaving home. In a commercial use, the office is unoccupied. It's 5 p.m., 6 p.m., and we can broadcast the unoccupied set points to all zones on the DZK. So when it comes to set point range configuration, The unoccupied set points become a little bit more restrictive. In cooling, we can do 75 to 86 Fahrenheit. In heating, we can do 59 to 72. I do like to point out that the unoccupied user mode is one of two defined what I call away modes for the DZK. So the away mode is something, be aware of the away mode. The away mode basically is something that allows the set point to be temporarily overridden. So when we command the unoccupied user mode, the DZK is in an away mode setting. And so we use those restricted set point ranges. We use more energy efficient unoccupied set points. But if somebody wants to locally override the set point, then the away modes allow for this temporary override of set point. And that is a configurable override anywhere from 10 to 120 minutes in the advanced settings menu of the DZK. And then essentially once that override time has elapsed, the DZK will resume that programmed unoccupied user mode set point. So it's just an easy way, using the unoccupied user mode is just an easy way to allow the DZK to set back its operation, but also allow for that temporary override. The vacation mode or vacation user mode, it's another away mode setting for the DZK. Again, this is probably something more specific to residential use. The set point range restriction becomes quite a bit higher than normal operation. In cooling, we can set anywhere from 84 to 96 Fahrenheit. In heating, we would set anywhere from 50 to 61. And then we have that same ability for, maybe a housekeeper, a dog walker, maybe just your neighbor is coming to check out your house and watch your TV. You can override these vacation user mode set points for that pre-configured override time, and then the DZK will resume that vacation user mode set point after that predetermined period of time. The last user mode available is the stop user mode. So stop user mode essentially sends the off command to all zones. And what this will do is it will open all of the dampers on the DZK. So the stop user mode is actually something, keep that in your back pocket for installers because it's useful if for some reason you need to open all outlets and you are doing some tab work and we need to adjust some dampers, some balancing dampers. We can essentially tell the DZK, hey, you know what, open all the damper outlets, and then you might disconnect the DZK control and just run the indoor unit fan, and that will help to open all of the DZK outlets. So when stop user mode has been implemented, there are two different ventilation settings that I'll discuss a little bit later, but just be aware when stop user mode has been implemented, the local ventilation setting will be ignored, but there is a global ventilation setting that I'll describe here shortly. That global ventilation setting will still be followed or implemented. So just be aware when the stop user mode is implemented, you'll still have occasional fan operation if you've engaged global ventilation. So the DZK I mentioned will control the indoor unit's fan speed. So the DZK does this by looking at the weight of the different DZK zones and taking all that kind of aggregate demand and deciding how to control the VRV indoor unit. So essentially there are three different choices that the main thermostat can make as far as how to apply this fan speed control algorithm. There's a silence setting, there's a standard setting, and there's a power setting. And the easiest thing to think of when it comes to these settings is the silence setting is really going to bias this algorithm towards trying to keep the fan speed as low as possible. The power setting is going to bias this algorithm to try to keep the fan speed as high as possible. Standard is really the default setting, and it's kind of, I guess, the Goldilocks setting. It's right in the middle. But the idea is silence requires a greater demand of total zones to actually increase the fan speed of the indoor unit, and then similarly, power requires less demand of zones to ask for a higher fan speed. So it's just a way that we can adjust the way the DZK controls the indoor unit fan speed operation. I'm not going to go through this table in a ton of detail. So I mentioned the global ventilation setting. So global ventilation is a setting that's used to essentially circulate air to all of the zones on the DZK during periods of time that there is no cooling or heating demand. So this is a configurable setting, and essentially we have two different setting options for global ventilation. We can tell the DZK to run this global ventilation setting every 5 to 40 minutes in 5 increments or 5-minute increments, and we can tell it to run the fan for 5 to 20 minutes in 5 increment settings. So really what this means, the example on the screen, we might configure every 10 minutes, run the indoor unit fan for 5 minutes. So on the left side of the graph here, the gray lines, we're basically assuming there's no cooling demand, there's no heating demand from the DZK. In that case, essentially every 10 minutes, the DZK will open all of the zones and it will run the indoor unit fan for 5 minutes, and it will turn the indoor unit fan back off. And then 10 minutes later, that same sequence will happen, all the dampers will open and the fan will energize. Once we hit that red portion of the graph here, basically if there's a demand for heating or cooling, then this global ventilation algorithm becomes ignored. The DZK delivers heating or cooling demand or heating or cooling capacity to meet the demand as needed. And then once we've reached that point where we've satisfied all zones and we are back to a period of no heating or cooling demand, this global ventilation setting is resumed, and we'll keep waiting every 10 minutes to run the fan for 5 minutes. So it's relatively straightforward, and it just gives you this option to allow the VRV indoor unit to circulate air and bring ventilation. If you're bringing outside air to that fan coil, we can bring ventilation to all of the zones on the DZK. The alternative to global ventilation, there is a setting called local ventilation. And as you might expect, this is something that is engaged individually at each different zone. So the local ventilation setting, really what we do is we enable this at the local zone. And when there's a period of no heating or cooling demand, that particular zone will open and the indoor unit fan will run so that we can deliver ventilation to an individual sort of localized zone, but not necessarily ventilate every single zone on the DZK. So just keep that in your back pocket, the two different options for how we can run global or local ventilation for the DZK. The DZK also features auxiliary heat outputs. So those are two outputs that are directly on the DZK's main control board. So the DZK can control up to 2 stages of auxiliary heat. There are a couple different settings as to how we can configure this auxiliary heat. So you have the option to configure auxiliary heat either as kind of disabling it. 0 would be a no auxiliary heat. A 1 setting would be indicative of a single stage auxiliary heat, and then a 2 setting would just simply mean 2 stages of auxiliary heat. We can configure auxiliary heat to either operate as auxiliary heat is the first supply of heat, or the indoor unit's heat pump heat will operate as the first supply of heat. So just be aware we have that option to configure within the settings of the DZK. And then also we can configure how the indoor unit's fan will react to an auxiliary heat demand. So you have essentially 2 different settings of the type of auxiliary heat device that's being connected. So the DZK sort of recognizes 2 different options, either electric heat or furnace heat. And really the intent there is the electric heat setting on the DZK will cause the indoor unit's fan to run when there is a demand for auxiliary heat. The furnace setting will basically, it's implying to the DZK that there is another source of heat that does not require the indoor unit fan to run. So maybe baseboard radiators, radiant panels, radiant in-floor heating, anything that doesn't require the indoor unit's fan to actually force the air through the ductwork we can use that furnace setting to basically tell the DZK we don't need to run the indoor unit fan when we're controlling auxiliary heat. It is important to recognize that this auxiliary heat is essentially like a system level auxiliary heat. So we have these two different contacts. What that means is we don't have these two different contacts for each individual zone. It's a system level auxiliary heat demand. So just be aware that is somewhat of a limitation with the DZK plenum design. So I do want to go through the three different thermostats that are available for the DZK. So there are three different thermostats that we offer. One is the DZK MTS, which is the wired thermostat. There is the DZK ZTS, which is the wireless thermostat. And there's the DZK LTS, which is the wireless light thermostat. So first, I just want to quickly cover the DZK MTS, the wired thermostat. So the wired thermostat, this redesign when we launched the third generation of DZK, this was a very nice feature improvement versus previous generations of DZK. It's a much more robust construction of the DZK thermostat. It's 3.62 by 3.62 inches square, the face of that wired thermostat. And then it's about 15 millimeters deep. So it's a much more lower profile than previous generation DZK thermostats. But the wired thermostat features a full color touchscreen display. This wired thermostat can be configured either as a main or a zone thermostat. So keep in mind again that one thermostat has to be configured as the main thermostat for the DZK. But if you don't want wireless thermostats, you don't have to use wireless thermostats. You can use all wired thermostats, and several of those wired thermostats will be configured simply as a zone thermostat. So this DZK wired thermostat has a glass face with a steel bezel, and that's really a common form design for all of the third generation DZK thermostats. This offers set point control, mode control, user mode control, and the airflow algorithm control are available with the wired thermostats, but only when that wired thermostat is configured as a main. So just keep in mind, mode, user mode, and airflow control, those are functions that are controlled by the main thermostat of the DZK. We can enable or disable local ventilation with this thermostat. We can enable or disable an off timer. And we can use any of the wired thermostats to configure the advanced system settings of the DZK. Now, I'm not going to go through the complete overview of all of the different icons that are available or that are part of the screen of the wired thermostat, but what I just want to reiterate, those top three icons on the display, they represent the mode, the user mode, and the airflow control. Those are essentially adjustable if you've configured that wired thermostat as the main thermostat. They are not adjustable. They are essentially read-only. They're kind of grayed out to the user if that thermostat has been configured as a zone thermostat. I do like to point out also, so you see kind of the middle of the display. In this example, it says zone 01. We can see the current room temperature, current relative humidity. We can use any of the wired thermostats to navigate to other zones and rename those zones. If you don't want it zone 1, you want it office, you want it master bedroom, you want it living room, we can easily rename zones within the DZK by just doing a long press on the name of that zone. Doing a long press allows you to edit that zone name. And then ultimately that zone name will get broadcast. If, for instance, my master bedroom is using a wireless thermostat, I can navigate to my master bedroom using my main wired thermostat, and I can rename that zone, and that zone name will end up being broadcast to my wireless thermostat. So a long press allows me to rename the zone. A short press allows me to just access remotely other zones that are not normally controlled by this thermostat, and I can still set that zone set point. I can turn that zone on or off or I can control that zone as I need to with any of the wired thermostats. So I'd like to point out that the wired thermostat, the background of that wired thermostat screen, the shade of, or the color shade of that thermostat will change depending on the actual operation mode of the zone. As shown as examples on the screen here, when the DZK is in cooling operation, we can see the little snowflake icon at the top left of the screen. In that case, when that zone is currently in cooling operation, the shade of that color screen will turn blue. When the DZK in that particular zone is operating in heating operation, you can see that the mode icon changes to a sun. In that case, the background of the screen turns red. So keep in mind, if you are maybe training your service personnel, your customer service support, if the screen is red, that doesn't necessarily mean something is going wrong. That might mean that the DZK is just in heating operation. So when that zone has met the set point and the zone is currently satisfied, so regardless of whether you are in cooling operation or heating operation, once that zone is satisfied, the background color of the DZK turns green. So it's essentially a kind of an indication of thermo off. So in the image here, I can see the snowflake icon. That particular DZK is in cooling mode, but my particular zone there is satisfied, so the background of the screen just turns green. And then last but not least, if that stop user mode is implemented onto the DZK, then the background of the screen turns purple, and you can just kind of quickly at a glance recognize that stop has been commanded to all zones and I've stopped the operation of the system. So the wireless thermostat is the DZK ZTS-3. It just indicates that it's a third generation, and the W just indicates that it's white, the white bezel. So from a form factor standpoint, this shares the same 3.62 by 3.62 inch faceplate, also about 15 millimeters deep. So the wireless thermostat is a low energy backlit e-ink screen. So the idea here was to develop a thermostat that really had a very long battery life, very low battery usage by utilizing the e-ink screen. So it has that same glass finish and steel bezel, but the wireless thermostat is controlled with capacitive touch buttons that we'll see in the next couple slides. This allows that zone level control for set point operation, enabling or disabling local ventilation, enabling or disabling the off timer. But just be aware this can't be configured as the main thermostat. So the wireless thermostat is always a zone thermostat, and it's powered by a CR2450 battery. It's sort of that quarter-sized small battery that's included from the factory. And that battery, in combination with the e-ink screen, should have approximately 2 years of battery life. The wireless thermostat has up to 130-foot wireless signal range, just depending exactly on what the construction conditions are of the space, but at really at maximum we indicate 130 feet of wireless range. So the slide here shows the different icons that are displaying information to the user. Again, I'm not going to go through all of these in detail, but what I want to point out is that the icons that you're seeing on the screen here, these are basically display icons. It's not a touch screen thermostat. So we're reading the information from these different display icons, but we're going to control the wireless thermostat using the capacitive touch buttons that surround the actual display. So on the left side of the thermostat, there is a small button that acts as the menu button for the wireless light, or I'm sorry, for the wireless. And this allows us to access local ventilation. That's where we can turn on and off the off timer. It's where we can access just information of the thermostat. You can see firmware, communication strength, etc. I do have a bullet point here on the screen that says zone navigation. The standard requirement is that one wired thermostat has to act as the main thermostat for the DZK. If for some reason that main wired thermostat has failed. In that case, essentially if the DZK is not detecting any of the wired thermostats, there is a zone navigation menu option that will sort of magically become available for the wireless thermostats. And that just gives the user still the availability or possibility to navigate to other remote zones and command and control those zones from a wireless thermostat. But by default, that is not something that will be seen by the user of the wireless thermostat. That happens only when the DZK ends up losing communication to the wired thermostat. On the right side of the screen, you'll see a set of graduated lines. These are also capacitive touch interface buttons. The standard use of these buttons is really to set the set point of the wireless thermostat. So if we swipe up or swipe down, we'll set the set point either up or down by several degrees. If you tap in the top half or tap in the bottom half of those graduated lines, it allows for really finer control. So there's single digit increments, 74 to 75 to 76. So tapping allows for that single adjustment of set point. Swiping will generally jump 4, 5, 6 degrees as you swipe up and down on that capacitive interface. The power button at the bottom right just turns on and off the wireless zone. And then I always like to point out that the air zone icon that's at the bottom of the screen, that is actually a button that is used. It's used to confirm menu selections when you're navigating the menu. Pressing the air zone button is essentially like pressing enter. And that air zone button is also used to wake up the thermostat if it's gone into the screensaver mode or kind of screensaver display. So the third thermostat that we offer is the DZK wireless light thermostat, which is that DZK LTS-3-W. So the wireless light shares that same form factor, 3.62 by 3.62 inches by about 15 millimeters deep. And the idea with the wireless light is to have a sort of very limited functionality, low-cost zone-level thermostat that allows the user to make some set point adjustments, turn on and off the zone, but really limits the complexity and the interaction between the user and that DZK zone. So the wireless light uses colored LEDs to indicate the operational status of the zone. The kind of display or the lines that you see on the actual face of the thermostat are also capacitive touch buttons that the user uses to control their particular zone outlet. And so what the wireless light thermostat offers is the ability for the user to adjust an offset from a base level set point. So essentially, one of the wired controllers can be used to set the base set point for the wireless light zone. Maybe the main thermostat has been used to set a 70-degree base set point for the wireless light. The user can then adjust either up or down in 1 degree Fahrenheit increments from that base level set point. 70 might be the base, so that means we can adjust up to 73, down to 67 in those 1 degree increments. The wireless light is also powered by a CR2450 battery, also has about a 2-year battery life and about a 130-foot wireless signal range. So how exactly does a user interact with this thermostat? So the power button turns on and off the zone, but that power button will also give some indication as to what mode of operation that the DZK is in. So keep in mind, again, the main thermostat sets the mode, and so the wireless light thermostat will give some display feedback to the user so that they can see what the mode of operation of the system is. So if that power button is red, that means the zone is in heating mode. If the power button is blue, that means the zone is actively in the cool or dry mode of operation. Once that set point is satisfied, you would see that power light turn green. And if the stop user mode has been implemented, that power light turns purple. So that power light, it also reflects or it helps the user understand whether or not the zone is actually on and active. So keep in mind that the first touch onto the wireless light will essentially wake up the thermostat, and then the second touch on the power button will start to sort of modulate the operation. So the first touch is a wake up, and when the user touches that power button, if the LED is remaining solid as either red, blue, green, or purple, that's just telling the user the zone is active. If that power LED is making a slow flash in any of those four colors, that's essentially telling the zone or telling the user that that zone is currently off and has not been activated. So user presses that power button to wake up. They kind of assess what the current status is, and if they want to turn the zone on, they press the button again. If they want to turn the zone off, they press the button. So the graduated lines to the left and right of the power button are where the user will interact with this thermostat to adjust the set point up and down. So what you'll see is there are backlight or LED backlights to these graduated lines that will just simply reflect if the user has adjusted that set point offset up or down. So I mentioned before 1 degree Fahrenheit increments for a total of plus or minus 3 degrees Fahrenheit. There is also a configurable menu setting so that we can adjust that essentially to degrees Celsius, but ultimately the result is plus or minus 3 degrees Celsius or approximately 6 degrees Fahrenheit. Gives a little bit more temperature range, but the increments are a little bit less flexible versus individual 1 degree Fahrenheit offsets. I mentioned before that there is a DZK BACnet interface that we can use to essentially command and control individual zones for the DZK. So the DZK BACnet interface, the model number here is DZK-BACnet-3. So again, this is a third generation component for DZK. It's only compatible with third generation DZKs, but this is a plug and play device that is compatible with BACnet IP. And it supports change of value notification for the different command points on the BACnet side. So from a network topology example point of view, you kind of have two different options here. If we are using the BACnet gateway with a VRV system, then keep in mind this DZK BACnet card that's really sort of upstream of the BACnet interface. We don't really command or control the DZK BACnet card through P1, P2, or F1, F2. This is all sort of upstream on the BMS side. There's also an option if we use the iTouch Manager with the BACnet client option. We can now basically integrate those, the BACnet command and control points of the DZK BACnet cards back into the iTouch Manager to make for a kind of a much more simplistic solution if we are using the iTouch Manager as the building front end. So what do we get out of the BACnet interface? There are 14 different BACnet points from a DZK system standpoint. 12 of those points are read-only, 2 of them are read-write. So I will just point out those read-write points. We can control the DZK's mode of operation. We can control the DZK's user mode. And then we can monitor a lot of other additional information from the DZK from a system standpoint. There are also 12 different BACnet points at an individual zone level. 6 of those are read-only, 6 of those are read-write. And so essentially you have the ability to command and control zone level set point. We can turn on and off local ventilation. We can turn on and off the zone. We can also monitor that zone's measured room temperature, the demand of cooling and heating percentage. We can even monitor what position that zone actuator is actually positioned at. Out of those 4, essentially 5 available steps, 0 is closed, but 1 through 4 as far as the zone outlet step. So it gives you a lot of this centralized control or a view into the operation of each zone from a centralized control standpoint. So what does this look like from an installation perspective as far as wiring the DZK? So what you see on the screen here is just the DZK's control board that's factory mounted inside that enclosure we saw earlier in the slides. So essentially we're wiring, excuse me, the DZK on P1, P2 back to the indoor unit. We still have to have a BRC 1E73 to allow that indoor unit to properly operate. So keep in mind, we need the nav controller also wired on P1, P2. We have the two different auxiliary heat outputs that we looked at before. The DZK does have the ability to take either 120 volt or 240 volt power supply. It's a single phase power supply. The top side of the screen here, you'll see the wired thermostat, where this wires back to the appropriate wiring harness landing point for wired thermostats. You'll see up to 3 different landing points for wired thermostats. So if you have 6 different wired thermostats, you end up having to double up and wire 2 different wired thermostats to each of these wiring harnesses. There is a very important switch on the DZK's main board. It's SW1. We can use that to open the wireless channel so we can start pairing the wireless thermostats to the DZK. We also can use that to essentially reset the DZK's main board if you essentially want to wipe all settings and go back to factory. I do just want to point out, I mentioned here SW1 is used to open the wireless channel. You can also use the wired thermostat once you've connected that in to open the radio channel for pairing those wireless thermostats. So you have a couple different options. Sometimes the switch is easier. Sometimes it makes a little bit more sense to do that from the wired thermostat. So the resources that are available for the DZK, jump onto Daikin City or DaikinAC.com. There's a selection guide. You'll see installation manuals. There are quick guides that are printed and actually included with the products in the box, but those are sort of a very simplistic installation manual that are ideally simplifying the installation process, especially if somebody has to maybe replace the main board of the DZK. But all of the typical literature and marketing resources are available on Daikin City and DaikinAC.com. So just to wrap up, the DZK, the idea behind the DZK is to offer this, I typically call it a budget-conscious solution for giving individual zone temperature control from a single fan coil unit. We have that optional backnet IP, backnet integration card to really give us some good flexibility for controlling these individual outlets from a centralized location. But the DZK is a bolt-on accessory that's compatible with the FXMQ and now the FXSQ, the FDMQ, and the FBQ fan coils. And there are 3 different thermostat options we looked at. The wired thermostat, in which one of those has to be the main thermostat for the DZK, and there are 2 different wireless options, kind of the de facto standard wireless DZK ZTS and that wireless light thermostat to give a very basic function, kind of basic user interface to control the zone outlets. So with that, Catherine, I think we'll wrap it up and just open it up for questions.
Okay, great. Thank you so much. So just a couple quick reminders, of course, if you know, use your chat box. We'll be happy to answer your questions now. I did want to mention, of course, you will receive a follow-up email a little bit later today with a link to the webinar recording. So if you'd like to refer back to it or share it with someone who might be interested, it will be in your email. And of course, there is a post-webinar survey, so feel free to provide some feedback. We do always look forward to hearing your thoughts. And one question that came in is the backnet card backwards compatible?
It is not. So if you had an older DZK, there's a DZK Generation 2 backnet card. Unfortunately, I didn't put it in the slides, but there's a compatibility matrix on the Daikin City library. And the easiest way to think of it, and we had these 3 generations. There was a Generation 1, there was a Generation 2 that added a -2 to all the model numbers. There's a Generation 3. If you have a 2nd generation DZK, you have to use a 2nd generation DZK backnet card. If you have a 3rd generation, you have to use 3rd generation backnet card. If for some reason you have like an older DZK out there and you want to upgrade to BACnet, it's not impossible. Reach out to me and I can kind of explain, but it basically involves, you would have to change the main board. You would also have to change the thermostats. But it's possible that we still have some second generation BACnet cards in stock if you have a second generation DZK out there and you're looking for BACnet compatibility.
Okay, great. And that is the only question that we've received at this point. So, nope, sorry, another one just came in. So if you're typing things, definitely keep sending them in. Let's see. Is the FBQ, it looks like XXT series, also compatible along with the as stated FBQ XXP? Is anything different for the T series?
I would have to check. To be honest, I'm not familiar with the latest FBQ. The easiest way to think of this, because DZK works on P1, P2, if there's no kind of geometric change with the newer generation of FBQ, the DZK will still work if it is a kind of a bolt-on straight matchup. If there's, for some reason, there's been some change with the geometry, functionally the DZK would still work, I suppose, if you made some transition to the plenum box. But as far as I know, FBQ, whatever the latest generation would be, it should still be P1, P2, so the control will still work. I think it's just a question of geometry matchup.
All right, great. And again, that is all that we have. So if you think of anything else when you leave the webinar, first, you can tuck it into your post-webinar survey. I'm going to be forwarding those over this afternoon. And second, you can always email me at deckenwebinars@deckandcomfort.com, and we'll make sure to get your questions answered. With that, Kevin, I just wanted to see, oh, nope. And every time I think we're wrapping up, we're not, so that's good. I'll just keep going. One of the last slides showed 4-wire standard shielded. When is that used?
So the little dash line, 4-wire stranded shielded, that is for the COM wire for the wired thermostats. So keep in mind, like typical P1, P2, stranded non-shielded. The 4 wires for the wired thermostats of the DZK.
All right. And so, Michael, hopefully that answered. Oh, yep. And that did. Thank you very much for that additional info. So, Kevin, I wondered if there's anything you'd like to say in closing today.
Nope. I appreciate everybody's time, and I thank you.
All right, great. Well, thank you so much for the presentation. And for everyone who took time out of your busy schedule, whether you're here live now or later on the recording, we do appreciate it and look forward to talking to you on another webinar soon. Have a great rest of your day, everybody. Bye-bye.